Hi everyone, my name is Blaze, and in this Corona era, this is a video being published on April 3rd. We we have a lot of charts being thrown at us, a lot of building up of coronavirus cases, deaths, and stuff. And so I thought I'd throw together a quick tutorial on how to compile big data using Pandas with this data that's just out there for us to use. And so with this link, I'll post it in the description. You have access to all of this raw data that you would be able to process and manipulate in your own way. What I just did is I just used the total confirmed cases. Over here on the right, you can select data, and then you can download it as an Excel, spliced values data set. Or you download it as a CSV, and you can open it as in an Excel, as a text, as whatever, which will kind of be important when you start to process this all. Anyway, so today I just wanted to run through processing data and visualizing it with Pandas. Now Pandas uses matplot, lib.pyplot, and numpy, so it's essential to import both of those libraries. And again, yes, here we will give a basic intro to visualizing data using the total cases of COVID data received from that website that I'll post in the description. And so when we have this data to process that's outside of our actual coding unit or coding file, we try to read it in. And the way we read it in with Pandas is with the command pd.read _CSV or _XLS if it's an Excel file, and there's a bunch of different variations of this pd.read. And so then you pass in your file name, and unless you want to, the easiest way to do this is just to save this file in the same directory as your coding file so that you don't have to punch in a new directory and have the program actually go and draw from a different directory. It's easy to just pair these up together, and so I save this in the same file. And so if I go here, I have my graphing total cases.ipy with my total cases of COVID-19, which I downloaded from the website. So these are the same directory. So I don't need to tell the program where to receive this CSV file. Just to show you what this would look like, or this looks like, is essentially, it looks the same as if you were just opening up in an Excel file. You have this entity, Afghanistan, it just countries alphabetically. Here you have your codes in case you want quick access. You have your dates, and then you have your recorded COVID-19 cases. I changed the name for this in the actual file because it was really long and I got tired of typing it all out. So that's why if you just copy my code completely with access to this specific column, it won't work for your case. So, we'll get there. Anyway, this is what it would look like. And so basically, if you want to access a specific country, I'll show you how to do that, and then graph, and I'll show you how to do that. But okay. So we're going to redo this. We'll save A, and then we'll just plot A and see what it shows us. Well, if I just plot A, right, this is data from all countries, and so you can see kind of little blips, and that's because the way this is all organized is by date, well, by country, then by date. And so every time, April 3rd rolls around, it's going to have a higher number. April 3rd, et cetera, et cetera. And then it'll drop back down to 0 because back at December 31st, there was probably 0 cases in that country. But whereas April 3rd, there's probably the max. And so that's what it would show if you just graphed everything. But we want a little bit more control so that we can, compare country to country and not just throw data into a graph. So here, I don't know, we can delete that. So here, the way you retrieve certain columns from a data frame, in Pandas we have series and we have data frames. Data frame is essentially this whole table, where a series would just be one row. And so when you want to receive a certain data frame, a column from a data frame, all you have to do is pass in the name for that column from our data frame, so df or A lot of people use df. I saved it as a, so I used a. And then entity, which will correspond with our country. Date, which will correspond with our date. And our COVID-19 cases, which will correspond with our COVID-19 cases. Now this is really just going to splice out this code column. So we can go ahead and run that. I guess that's just to show you how to access. So yeah, so our code column got spliced out. And so you can see we have 8,597 rows by 3 columns. 1, 2, 3. This is our index column. It just shows you how many. It keeps count as you go down the rows. Now if I just show you how to splice data frames really quickly, there ends up being about 85 to 95 depending on the country and depending on the data that this website is stored. In the case of Afghanistan, it's 85, and so I can actually splice out the first 85 rows of this data frame just by using almost regular splicing methods that we would use for NumPy arrays and lists and stuff. And so if I print out this A of G, you're going to get a data frame of just the Afghanistan. But what if you don't really know what your counts of your rows are? In that case, you're going to have to splice it a little differently, or you're going to have to search by name. And so we can do that pretty easily down below, but we'll get there. And so if I want to graph this data frame, it's really easy in Pandas. And so if I just go x equals the columns of Afghanistan's date and COVID-19 cases, and then we'll plot the figure and we'll plot the cases and run it. And it should just come out as a fairly exponential graph. So we have 0 to 200 cases, but you notice on the y-axis, I didn't index this correctly, and this actually corresponds with our actual index of the data frame, 0 through 84. So if I went and passed the US in here, it would be like 8,000 whatever to 9,000 whatever. So I'll show you how to index your Y correctly. So speaking of the US, I'll just jump into the US. So I define this US data frame as a.loc of a entity equals United States. So this is how you search for that specific name, United States, in this specific column, the entity column. So in this entity column, I searched for just the United States and I spliced those out. And so I stored that then as my US underscore data frame. Then I stored US as the US underscore data frame of just the date and the COVID-19 cases. I could have done that all in one line, but I kind of wanted to show how to do that. Now, in order to get the date range, so we want our dates essentially to be the indexes of the Y, or we want that to be, that to be on our Y-axis. And so the way Pandas works is it kind of uses the index automatically as the index to the Y. And so we are going to pass through our date range and have that be the index instead. And so our date range is going to be the US of the date. And so then you can see in our new data frame, I just stored this as df, we will get the US, I pass through the US, our columns equals COVID-19 cases, and then I change the index to the date range. And then in order to make this really pretty, you can pass in this really cool fake comma axis equals plot.subplots platform. This allows you for some unique access to certain functions within the plot. I'm not going to get that into, but in this case, I messed with it with my axis title and stuff because I needed to process that a little bit. So I'll go ahead and run that, and you see immediately that you can't even read the y-axis, right? If you look at our y-axis, they're all, or our dates, it's pretty clunky date labels, and so these are definitely going to overlap if we were to just graph them all together. And so to order do that, we can do actually a really cool trick using a different library or using a variation of the matplotlib library. So matplotlib.dates as mdates, that's just what people import it as, and you can store the dates as mdates.number to date, mdates.datastring to numbers of the US of date. What this does is this automatically converts the dates we had stored in this data frame to dates that then we can control. And so it makes it kind of numerical, and then the plotting mechanism can actually control what the y-axis is in this case. So then I pass in the fig and the axis 1 again to this, and then I mess with it here. And then the thing is, now that we have our dates and actual things in a format that our graph can manipulate it with, we can just auto fit it. And so that's what this method does, auto format under X date. And so then if I go ahead and run this, it fixes all of our dates. It came out a little spaced out. I could mess with it a little bit more and have a little bit more increments or zoom in on a certain area, but that's the basis. So now I have all these nice dates that aren't all overlapping and stuff. And so you can see, okay, April 2020, the first in the US, there was almost 250,000. I think as of today, they're like 266,000, but I try not to stay that updated. It's a little overwhelming. Anyway, so then if I go ahead and like, okay, great, I can get my US graphed pretty easily. Might as well just graph this against Italy. And so a bunch of journals have done this. Obviously, they go in and actually make the graph look a little bit more pretty than I might have by just throwing it all together in a couple minutes. But if I go ahead and create Italy, or I grab Italy from the A data frame that I made at the very beginning, it'll look something like this. It's like, okay, great, Italy is going to be, boom, all of this. I just went ahead and wanted to show the date, the COVID-19 cases. And so in Italy, through these dates, there were this amount of COVID-19 cases. And so then I just went ahead in this last little part, I graphed them on the same graph. Since Italy and the US both have 95 dates recorded, I was able to do this. If, say, one country didn't report one day, it would be a little bit trickier to graph it against each other because of how finicky data is with Pandas. But since both of these had 95 rows in 2 columns, but they had 2 columns, there's 95 rows in Italy. In Afghanistan, I couldn't graph it against the US, partially because I bet Afghanistan didn't report, I guess it looks like 10 days out of this span of December 31st to today. But the US does have 95, so I graphed it against the US. And it's the same thing here as up here. All you do is add in another axis to plot, but you plot it under the same axis and maybe change the color so that you can compare the US to Italy. And you can see like, oh, the US is still growing very rapidly and Italy is starting to flatten the curve. Of course, there's a big population difference between the 2 countries. And so then if you go in and actually change the cases of COVID per, or the percent cases of COVID per the country's population, you might get a different look or something like that, because since Italy's percentage is already so high and their population isn't going to be as large as the US's, you'll get a different plot if it's just the cases versus the percentages. Anyway, I hope this was a cool intro, and there's a lot of data out there, and I encourage you all to go out there, grab it, and teach yourself in this time of quarantine.